So we're picking up for where we left off yesterday. And I'm realizing it'd be nice if I had one of these slides where it was completely filled in all the way, so I don't have to fill it in every time. But that's fine. Now, the unit circle, we filled it in yesterday. We have that. It's very handy. It's a very helpful sheet because it'll help us in a few ways. One, especially with what we're doing here, so we'll continue on with problem B because we finished problem A yesterday, is going from a given angle to the values of sine, cosine, and tangent, secant, cosecant, and cotangent. But it also works the other way, because if I know a value for sine or cosine, what it should equal, I can get back to the angle. So what we're looking at first is sine, cosine, and tangent of 5 pi over 4. And if we look on the unit circle, 5 pi over 4 is in the third quadrant. And this is going to be our negative square root of 2 over 2, negative square root of 2 over 2. So incidentally, sine is negative square root of 2 over 2. Cosine is, incidentally, negative square root of 2 over 2. And now we need to figure out tangent. Well, tangent is sine of our angle over cosine is our tangent value of that same angle. Well, for us here, both sine and cosine are same thing. Anything divided by itself is. And since they're both negative, it turns out to be positive. Oh, that's right. I'm already on there. Now I think you have space below this, so I'm going to write it off to the side and then I have to erase. Secant of 5 pi over 4, cosecant of 5 pi over 4. About wrote tangent again. Now, of all of these here, cotangent is going to be the easiest one to calculate. That's going to be what? Because it's just 1 over tangent, yes? Well, tangent's value is, so 1 over 1 is. Now, secant is 1 over, which one? Sine or cosine? Secant, SEC, it looks like sine, but it's actually cosine. CSC looks like cosine, but it's actually sine. So secant's 1 over cosine. So we'd have 1 over negative square root 2 over 2. Well, over 2 negative square root of 2. Now, it seems like there should be more numbers there, but if you remember back to yesterday with tangent, where we had 1 over, or going from tangent to cotangent, cotangent to tangent, because one of them was negative, or one of them was square root 3 over 3. And we did 1 over it, we flipped it, and it just became the square root of 3. And we saw later that it did simplify out. Well, yes, we get this here. Now, yeah, that is the proper way to do it. I still find it interesting I did it that way because secant and cosecant for this are going to be the same because sine and cosine were the same. Because the other way we could have done this is said negative 2 over the square root of 2. We just flip the value, which still works out to be negative square root of 2. And incidentally, are 45 degrees any of the 45 degrees with reference angles of those? So we're looking at pi over 4 over here, 7 pi over 4 for the 2 and the third and fourth. Up here, obviously, well, that's the wrong spot. Pi over 4 are 45 degrees. Or over here at 3 pi over 4. These here are always going to be square root 2 over 2 for both. That's one of the ones that's nice to know. It's not called yes. Welcome. Because these will always be square root 2 over 2 for both. The thing we just have to be careful with is the sign. Which sign is connected to which one? Because for quadrant 1, they're both positive. Quadrant 2, our cosine is positive, the sign's negative. And going with the rest of those there. Questions on this here? Okay. Clear that all out. Let's look at C. So we're looking at sine of pi, cosine of pi, tangent of pi. Now sine of pi, so pi is over here, and we have negative 1, 0. And sine is which one, the x or y value? It's the y value, so sine is, I don't know why I keep doing that, 0. Cosine ends up being the negative 1. Now, tangent is sine over cosine. 0 over negative 1. Well, that just works out to be 0. Let's look at secant of pi first. So secant is 1 over cosine, or the flip of cosine. Well, 1 over negative 1 is just negative 1. We're good there, yes? What would cosecant be? Almost. Cosecant CSC is 1 over, so that's 1 over 0, which is undefined. So cosecant's undefined at pi. How about cotangent? So cosecant and cotangent are undefined at pi. Because if sine is 0, secant, if sine is 0, cosecant's undefined. If cosine's 0, then secant's undefined. If tangent's 0, then cotangent's undefined. Does that make sense? Now well, it doesn't go to if we get or told that secant, cosecant, really it's going to be cotangent is 0. That means tangent is undefined at that value. I mean, we could say, or try to say the other way, that if secant or cosecant 0, then sine's undefined. But that's not possible. Okay, I'm going to have to clean that later. Kill the fly. And part of the reason for that is, so I'm going to pull this up so that we can see it. Sine of x or cosine of x. If we see here, they repeat themselves like this here. So there's not a value where they're undefined. Now, we were going to get to this later, but we can look at it now. Sine of x to the negative 1. This is our cosecant, CSC. Enter cosine of x to the negative 1. And this is our secant. And if I graph these, do you see how neither the purple or the black one in their actual just secant cosecant without any transformations never hit the x-axis? So there's no way for either one of those to actually be 0, but there are set values for which they are undefined. They actually don't have a value. And the one we were looking at that was undefined was our cosecant, our 1 over sine. So let me clear this out, clear that out, graph. So we have this here. And I'd have to go back and remember how to do it, but second, calculate value, second, pi. We can see here that it flips up and down. There is actually a vertical line there. That's an asymptote. And we'll get more into those, especially when we start talking about the properties and the graphs and of these functions and how those asymptotes move. And we'll see that there. But questions on A, B, or C? Let's look at D. Now, on the unit circle, do we have negative angles? No. But I do know that most all of these are based off of pi over 3, pi over 4, or pi over 6. They're just different ones based off where they are. And positive, let's get to the big one. This direction's moving in a positive way. So we have pi over 6, pi over 4, pi over 3. And this movement here, from here to here, would be an angle of positive pi over 3. But which direction is negative? Clockwise, going down. Which means that this first movement here is pi over 6, which means this one here would be negative pi over 6. Because this one movement here, or 30 degrees, because this here is 0 or 360. So if I go down this way, because we said this one was, which is an angle of 30 degrees, which would mean that this is technically negative pi over 6, which means this one here is technically negative pi over 4. And if we come all the way down to here, we're technically at negative pi over 3. Now, what they told us, and on our unit circle, is that this is actually 5 pi over 3, yes? Well, if I take negative pi over 3 and add 2 pi to it, negative pi over 3 plus 2 pi. Let's see what we get. So there's two ways we can go about it. We can look at the unit circle, and even though we don't have them written, we can think of it in a negative direction. Or we can find our coterminal angle to it that's within the unit circle between 0 and 360, or 0 and 2 pi, and use it. So that means all the values for sine and cosine at pi over 3 still hold true. So for sine, it's negative square root 3 over 2. At cosine, we have 1/2. Now tangent's going to be sine over cosine. So for this here, we'd have negative square root 3 over 2 over 1/2. Now, I think most of y'all have the unit circle. Flip it to the back. Because, I mean, for y'all it's on the back. For me, I have it on the other side. What was tangent of pi over 3? Square root 3, yes? Okay, so we know pi over 3 for tangent square root 3, yes? On the front, so we're flipping back over, quadrant 4, we had the positive negative, yes? Tangent's value should be what? Negative, yes? And it said that sine and cosine, sine should be negative. We have that here, yes? Cosine should be positive. We have that. So tangent should be negative, and its value is the square root of 3. Now, in a calculator, fraction, negative second square root 3 over 2 over 1 over 2 is negative square root of 3. So we do get that, yes? Well, now we need cosecant of negative pi over 3, secant of negative pi over 3, and cotangent of negative pi over 3. Secant's the easiest one out of the group, because all we have to do is flip 1/2, and that becomes 2. Now we need to do the same thing with tangent and cotangent, which ends up getting us negative 3 square root of 3 over 3. 1 over second 3. Forgot that was supposed to be negative. So negative square root of 3 over 3. And if we flip the other one, we get negative 2 over second square root 3, which is negative 2 square root 3 over 3. Questions on any of this here? We feel pretty comfortable especially using the unit circle and getting this here. So we have this. Now we could try doing these in the calculator, negative pi over 3. So I could say sine negative pi over 3, close parentheses, enter. That's not the same number, correct? And what we found it to be was negative square root 3 over 2, yes? So maybe it's just approximating. Negative second square root 3 all over 2. Those are still different numbers, yes? And the reason I bring this up is if you see in the top, it says, what, D-E-G, yes? What do you think that's abbreviated for? Degree. What are we plugging in? Are we plugging in a degree measure? We're plugging in a radian measure. if you hit mode up at the top, you see DEG is selected. If I select RAD, radian, it has to be in this mode. So now if I do sine negative pi over 3, close parentheses, enter, we get the correct value. And this is a little early, we'll see it again. If I put this to the -1, all right, it doesn't like it. Okay, let's clear that out. So here, enter, we get this. Yeah, we have to do it ourselves. Otherwise, or 1 over sine of negative pi over 3. Didn't technically need that second set of parentheses. We can do this here. Now I'm curious. This is more curiosity than anything else. Nope. You literally have to put it as a fraction of 1 over. Otherwise, that calculator throws a fit. But that's how we can get those. Questions on this here? Domain and period of sine and cosine. The domain and the period of sine and cosine. So the domain is between -1 and 1 for x, if we talk about the unit circle. So the x values that we plug in are really going to be restricted with these here. And the y values are going to be between -1 and 1. And really, for sine and cosine, sine of an angle and cosine of an angle, for both of these here, we're never going to get the case where they're greater than 1 or less than -1. This is not going to work because they're restricted between -1 and 1. Now, are there ways for it to be greater than that? Well, yes. 2 sine, then yes, it can be greater than 1. But if we're solving it, we have to divide by 2. The actual value of sine or cosine for this here doesn't work. We have to do transformations. We have to apply something to it for it to actually work. Does that make sense? And it has to be outside of sine or cosine itself. I'm going to leave it for later when we actually start talking more into this. By definition, sine of t equals y and cosine of t equals x, because x and y are in the unit circle. You know that y is between -1 and 1, x is between -1 and 1. So the values of sine and cosines range are also between there. We also have this here, and we've kind of seen this with these coterminal angles. There's more than one for these here. In this plus 2 pi version for it will come into play when we start solving, because if the solutions are not restricted to being between 0 and 2 pi, we have every coterminal angle for that given value that will work. So we have to include that there. And there's some ways that we could get, especially with certain types of solutions, we can simplify it down a little bit, and we'll cover those when we get there. Similarly, the value of sine of t plus 2 pi and cosine of t plus 2 pi correspond to those values of sine and cosine of t. We've seen that already. Sine of t plus 2 pi n is equal to sine of t. Same with cosines. For any integer n and real number t, functions that behave in such a repetitive or cyclic manner are called periodic. They're periodic functions because they repeat themselves. A function f is periodic when there exists a positive real number c such that f of t plus c is equal to f of t for all t in the domain of f. The smallest number c for which f is periodic is called the period of f. So the period for a given function is the amount of time it takes for it to repeat its self of it. And I really don't want to see the comments that flare up because of it, and more hassle than it's worth. Now, cosine and secant are what we consider to be even functions. Even functions. Because it works out that cosine of negative t is the same as cosine of t. Cosine of the negative angle is equal to cosine of the positive angle. Sine, cotangent, cosecant, and tangent are considered odd functions because sine of negative t is the same as negative sine of t. We have that kind of flip to it. And we have this here. So really, cosine of negative t, cosine of t, we can already see that here. I think if we get some examples. Because 13 pi over 6, well, evaluating sine and cosine. So if we wanted to look at sine, or cosine with 13 pi over 6, well, 13 pi over 6 is not on the unit circle, because 13 over 6 is greater than 2. But we can think of it as an angle plus 2 pi. So if I take 13 over 6 and subtract 2 from it, we get 1/6. So pi over 6. So what we can say is with sine of pi over 6, pi over 6 plus 2 pi is the same as just sine of pi over 6. I think technically, I don't like how that's written, because we really would look at sine of pi over 6 plus sine of 2 pi, adding those two angles together, especially their values, because, wait, no, I'm sorry, I take that back, because it should really just be looking at, this here is the equivalent version of just sine of pi over 6, because our sine of 2 pi is just going all the way around the circle and back where we were, and we're just adding pi over 6 to it, which in our case is 1/2. Now, if we take the calculator, say sine of 13 pi over 6, close parentheses, 1/2. It doesn't bother it where that lands. So that would be negative 17 pi over 6. I mean, we can look at that there. Now, if we did cosine for this here, well, we're really just looking at cosine of pi over 6, which is 13, or square root of 3 over 2. We get that there. Yep. So I was right with what I was doing there originally. Okay. Which gives us that there. Now we could do the same thing with cosine for this here. So negative 4 pi, it went around 4 times, plus pi over 2. And we actually get the same thing here, so it's just really taking cosine of pi over 2, which is 0. Cosine of pi over 2 is straight up and down, so it would be 0. Questions on any of this here? So we have this here. Now, okay, I remember what I can do. Yeah, so we get our 0. Oh, okay, I erased way too much. So for sine of t equals 4/5, sine of negative t would equal negative 4/5 because it's an odd function. Does that make sense? And this is based off even or odd functions. Now, if we were told that cosine of t is equal to 7/9, whatever the value, and I was wanting to find cosine of negative t, cosine is considered to be an even function. So it's told us that cosine of negative t is equal to cosine of t, and we know that cosine of t is 7/9, which means cosine of negative t is also 7/9. Questions on this here? And I mean, we could do other things with it. We could, especially if we know that cosine of t is 3/5, and it asked us to find tangent of negative t. Well, tangent of negative t is the same as negative tangent of t. Well, we know that this is going to be sine over cosine. So negative, well, sine is 4/5. Cosine is 3/5, which ends up being negative 4/3 if we plug it in. And we can do more with that. Now, in the calculator, we've seen this here, especially 1 over sine of pi over 8, because we saw this when I was messing with it earlier in the calculator, especially the 30xs, the little one. We'll get these here. Now we do need to make sure it's in radians if we're plugging in a radian measure. And then if it's a degree, we need to plug in a degree value. Does that make sense? Yes? No? Okay. Now, this is the assignment. I'm going to give you, I think I'm planning on giving you sometime next week to probably work on it. 5, 8, 13 through 19 odd, 23, 25, 27, 37 through 40.